Okay, so we folded our paper, right? We spaced out our paper about an inch or so, and then we folded it, making sure that this was still an inch when we folded it, and then we stapled across the top, yes?
Yes.
Okay, this is going to be our notes today, right? So we are making a new what? Foldable. How long can we use this foldable?
Forever.
Well, until May, right, for me. I suppose you can use it in another class, but probably not for tests and quizzes and stuff like that. Like, I'm going to let you use it, right?
Forever and ever.
Exponents.
Oh, that's fancy looking.
You can write it fancy or not fancy. That's fine. I just for sure wanted to say exponents at the top. A lot of you can write way fancier than me. Okay, exponents. Got it? Now, before we go any further, we're going to turn it over. And what are we going to write on the back?
Our name.
Because am I going to let you use it on a quiz or a test if your name is not on the back of it? No.
Put a name.
Not anybody's name. It has to be yours. Yeah, please don't write my name on the back. Don't write Mrs. Kingston on the back. You're writing your own name on the back. Okay? There's only one of us. There only needs to be one of us.
And I forgot to.
Okay, so do you see how there's tabs? 1, 2, 3, 4, 5, 6, 7 tabs kind of things? So what we're going to do on the tabs is we're going to write the name of the rule and the actual rule, and then we're going to fold this section up right here, and that'll be a room for examples. Does that make sense? So on the first tab, we're going to write product of powers. Product of powers. Excuse me. Product of powers, the rule for product of powers is a to the m power times a to the n power. What do we do with the exponents when we're multiplying like bases? What do I do with the exponents?
You combine them.
How? What's the like mathematical word of what I do with m and n? Add, right? Add m plus n. Okay? When I am multiplying like bases, I add my exponents. Okay? Now, this is the example of the rule that you already know. Okay? X squared times x to the third. Well, if we're multiplying like bases and I add my exponents, what is x squared times x to the third equal? Perfect. You already know this. This is definitely something you went over in Algebra 1, these exponent rules. I'm not teaching you anything new when it comes to an example like this. What I am going to do is I'm going to expose you to something new based on the chapter that we're starting today. Okay? Here's the example for the stuff that you've probably never seen before, but it's the same rule. X to the 3/2 power times x to the 4/2 power. If I'm multiplying like bases, what do I do with the exponents? So what is 4/2 plus 3/2?
7 over 4.
7 over what? 2. Because when we're adding fractions, what do I do with the numerator? Add. What do I do with the denominator? Stays the same, right? And it has to be common for me to add them, doesn't it? Okay? So if it's not a common denominator, you've got to get a common denominator, but then you just add those two.
So you would just simplify one
Mm-hmm. Yeah.
Get it down to what it should be.
So this is exactly what you do, just like this. Okay? Add the numerators, leave the denominator the same. Okay? Any questions about that? Can you tell what our new chapter is about?
The exponents.
What kind of exponents?
Common. I don't know.
Fractions. They're called rational exponents because rational is a ratio, which is a fraction. Okay? All right, the next tab down is called power of powers. Power of powers. Okay? Power of powers, the rule looks like a to the m all raised to the n. If I'm raising a power to a power, what do I do with those numbers? M times n, right? M times n. You got that?
Wait, so we can multiply the A by whatever?
The a stays the same. That's the base. It's just the exponents that I'm messing with. Okay? So let's move this up so I have some place for some examples of this. X squared to the third power. This is the example that you already did in Algebra 1, but 2 times 3. X to the sixth. Very good. What if it looks like x to the 1/2 raised to the third power, though? What am I doing with the exponents again? Multiplying. So if it's okay with you, I'm going to write 1/2 times 3. Wouldn't it be easier if they were both fractions? Oh yes, that's exactly what I can do, right? 3 over 1. Now how do I multiply fractions? No. Straight across, right? The only time you cross multiply is when you have two fractions set equal to each other, right? This is just a fraction times a fraction. What's 1 times 3? And what's 2 times 1? 2, right? So this is x to the 3 over 2.
Miss Kingston?
Yes? Yes?
Yeah, Ethan,
Yes?
you send him to the office, please.
Can he come in about 10 minutes?
Yes.
Okay, thank you. Questions? Next tab is called Power of a Product. Now, that seems kind of familiar, right? Power of a product. Well, look at this one. What's this one called? Product of powers. So, are these two different rules? Product of powers versus power of a product? They are different rules, right? Notice I'm multiplying like bases and I have to add my exponents. I'm taking the product of powers. I'm multiplying like bases, so I know I have to add the exponents. When I have a power of a product, I'm actually multiplying two bases together and then raising them to a power. So the power of a product. Here's my product, and it's the power of that. Does that make sense? So tell me, what is being raised to the third power? Both of them? So a to the m power, b to the m power? Both of them are being raised to the m power. So a to the m power, b to the m power. Okay? Any questions about that? Now I do have a couple more examples of this one for you than rather just one on each side, because of the fact that it can, so many different things can happen. Okay, so we'll start with just this one. A times b squared. So tell me please, what is being squared?
A and B.
A and b. So a squared, b squared. Okay? But that's rarely what's going to happen. Most of the time you're going to end up having to combine rules. We just did power of powers. A to the m raised to the n. Well, now I'm doing a product, but I'm also raising what? Both of those to the fourth power, right? So what do I do with the 2 and the 4? Multiply. So x to the 8th, y to the 12th. Now I will tell you this, if people mess up on one, it's this one. But you're not going to, because I'm warning you ahead of time, right? So what do you think? What do you think about this?
2x to the third.
So I'm going to agree with that. X to the third, yes. Y to the 15th, yes. I agree with that. So that's the second most common guess, right? The first most common guess was just a 2. The second most common guess is a 6. But guys, what's happening to this 2? Doesn't it have an exponent of 1? And it isn't the exponent that's being multiplied by the 3? So it's 2 to the third, which is what? 8, right? 2 times 2 times 2? Does that make sense? Excuse me. So now let's go to this side. AB to the 2/3 power. What's being raised to the 2/3 power? A and B, right? So A to the 2/3 power, B to the 2/3 power. Now, on this second example on this side, I'm going to have to ask you to trust me for just a second until we can get to one of our later tabs, and then we will come back to this example. I want to have the answer written down for you, but I want to be able to come back to it and make sure you understand, because the first part, I don't think you will yet. Is that fair? Okay, so what I want you to write down is 4, and then what should I write down? A to the
2.5.
5/2. Good. And B to the 1/2. Okay? Because 5 times 1/2 would be 5/2. I know, I agree with you that that's 2.5, right? But remember, the whole section, the whole chapter is about rational exponents, so we need to leave them as fractions. Does that make sense? Okay? We'll come back to this example in just a minute. Okay? Let's go to the next tab. Quotient of powers. Quotient of powers. Well, if product of powers looks like this, I'm multiplying 2 like bases. What do you think quotient of powers is going to look like? I'm dividing 2 like bases, right? A to the m over A to the n. What am I doing to the exponents if I'm dividing like bases? Subtracting m minus n. Okay, quotient, Q-U-O-T-I-E-N-T, quotient of powers. So x to the 5th over x to the 3rd. What am I doing to the exponents? Subtracting x squared. Now, let me ask a question. Where was the bigger exponent? In the numerator, right? So I said 5 minus 3, and my answer was 2, so I left that in the numerator, right? Here's why I asked that. What if the problem looks like this? And I'm telling you right now, one of our next, not the very next tab, but the one after that is called negative exponents, and it's a way to never ever have negative exponents. Where do you think I'm going to do in this problem? Because if I did 3 minus 5, isn't that going to give me a negative exponent? But what I asked you to do was think about where the bigger one was and start there and end there. 5 minus 3, 2. It ended in the numerator. Now, I have over 1, so it's in the numerator, right? So where's the bigger exponent this time? Denominator. What is 5 minus 3? 2. I want to leave that in the denominator. So what's left in the numerator? Nothing, right? A 1? Because I simplified everything out, didn't I? I can't just leave it the bar over x squared. There has to be something in the numerator. And if you think about it, I simplified out x to the 3rd and x to the 3rd, and all that was left was x squared. But x to the 3rd divided by x squared is 1, right? Sorry, x to the 3rd divided by x to the 3rd anything divided by itself is 1. Does that make sense? Okay, so what if I have x to the 7/3 over x to the 2/3? How do I subtract fractions? What do I do with the numerator? Subtract, so 7 minus 2. And what do I do with the denominator? Leave it, right? It has to be a common denominator, but if it is, I just leave it, don't I? Okay? Ready for the next tab. Power of a quotient. Again, these two look a whole lot alike, don't they? They both have power and they both have quotient in the name of the rule. But think about what we did with power of a product. I was multiplying two things and raising it to a power. Guess what I'm going to do here? Divide two things and raise that to a power. And it's really the same kind of rule, isn't it? Because what I asked before was what's being raised to the m power? Both of them, right? So a to the m power over b to the m power. Good? So x over y to the 3rd power is the same as what? Very good. X to the 3rd over y to the 3rd. But this is also the place where I can start mixing rules again. A to the 6th power over b squared, but I want all of that raised to the 4th power. So what's being raised to the 4th power? All of it. So a to the 24th over b to the 8, right? Very good. So x over y to the 1/2 power ends up being what?
X to the half power over y to the half.
Very good. Ready for the next tab? I told you it was going to be already, right? Negative exponents. If I have a to the negative n, we want that to be 1 over a to the n. Negative exponents, a raised to the negative n power equals 1 over a to the n power. So here's the deal. I can teach you rules, right, which one is what I'm trying to do right now, or I can tell you silly stories to help you remember some of those rules. I have a silly story for you here. Okay? You see this x? Look at the exponent. This exponent, so sad. It's so sad. It's so negative, right? Where is it? Isn't it in the numerator? Where does it want to be? It wants to be in the denominator. When you move it to the denominator, it's so happy. And because there was nothing else with it, I keep a 1 in the numerator. 1 over x to the negative 4th. Look at this exponent. It's so sad. Where does it want to be? Yeah, because it's in the denominator right now, and it wants to be in the numerator. So when I move it to the numerator, so happy. But it's the exponents that we care are happy or sad, right? So if I have negative 2 x to the y to the negative 3, let me say this again, negative 2 x y to the negative 3rd, is the negative 2 sad? No. It's just probably grouchy, right? Yeah. Is the x okay? Yeah, it's where it wants to be. It has a positive exponent. Is the y where it wants to be?
Yes.
No, it is not. It is
So why is
so sad. See how its exponent is negative? Where does it want to be? In the denominator. And when I move it to the denominator,
It's happy.
so happy. Now, is that a silly story? A silly way to think about it? Yes, but if you remember it, is it worth it? Yes. X to the negative 1/2 power is so sad. It's in the numerator. Where does it want to be? In the denominator. And when I move it to the denominator, it is happy. 1 over x to the negative 3/4 power. This is so sad, and it's in the denominator, so it wants to be in the numerator, and when I move it to the numerator, it's so happy.
Do we not have to put it over 1?
You don't have to. You can if you want, though. Yeah, you can put this over 1 if you want, because there's just nothing down there anymore, so we don't really need to, but we can if we want to. Okay, last tab. Are you ready? Oh, they're super amazing stuff. Ready? Things I want you to remember. Anything to the first power is itself. Anything to the 0 power is 1. I'm going to show you a visual example of this in just a second on this side to help you hopefully remember that anything to the 0 power is 1. Okay? Here is the major part of the notes for this chapter. A base raised to a fractional exponent, a rational exponent. When this is what it looks like, I need you to remember that the numerator of the exponential fraction is the power. It's what we're used to having in the exponent. Okay, it's that number. The denominator of the fraction is the root. Here's what I mean by that. X to the 1/2 power, it's x being raised to the first power, but what root? That means I am taking the square root of x to the first power. Does that make sense to you? If I say y to the 2/3 power, it's y to the second power, but what root? The cube root of y squared. Does that make sense? The numerator is the power, the denominator is the root. So please let's go back to power of a product. Please let's go back to power of a product, and I ask you to trust me, and I told you we'd be back later. Well, now is later, right? And I said you're going to need to trust me to go from 16 to 4. Well, 16 to the 1/2 power, what am I asking you to do with 16? The square root. What is the square root of 16? 4. Do you see where that came from now? Okay. Back to the last page. Super amazing things. Okay. If this is the very top and this is the very bottom, I'm starting closer to the bottom. You see where I'm starting? Do you agree with me that 2 to the first power is 2? You told me that over here, right? Anything to the first power is itself. So do you agree that 2 to the first power is 2? What about 2 to the second power? Isn't it just 2 of the shape that I just had? So 2 of those. So it's just 4. Because I'm just doubling the shape, right? What about 2 to the third power? Isn't it just doubling this shape? So there's the shape I just had. and then I'm going to double it. So how many are there? 8. You okay so far? What about 2 to the 4th power? Aren't I just doubling this shape? So there's the shape I just had, and then I'm doubling it. So how many are there? 16, right? Now there's quite a few patterns here that I need you to notice. Okay? The first pattern that I want you to see is the pattern of the exponents. What's happening to the exponents? So from 1 to 2 to 3 to 4. Increasing by 1 every time, right? What's happening to the answers? How many squares there are? They're doubling, right? They're multiplying by 2. What's happening to the shapes? What shape is this? That's a rectangle, right? What shape is this? And then a rectangle and then a square. So what if we went backwards? What if we went this way with the exponents? What's happening that way? Subtracting 1. So what should be the next one? 2 to the 0, right? What's happening this way for the answers? I'm dividing by 2 every time, right? Well, what's this divided by 2? 1. Even the shapes, square, rectangle, square, rectangle, square. How many squares are there? 1. 2 to the 0 power is 1. But it even keeps going. It even works if you keep going. 2 to the negative 1. Wouldn't that be the next one if I was going down by 1? What shape should it be? A rectangle? 1/2. Negative exponent says it's in the numerator. It wants to be in the denominator, which would be 1 over 2 to the 1st power, which is 1/2. What about 2 to the negative 2 power? Shouldn't that be a square? Which would be 1/4. Well, 1 over 2 squared, which would be 1 over 4. Does this help you see why anything to the 0 power is 1? Any questions about that? Look back over your foldable real quick. Look at each one of the little tabs that we have. Do you have any questions about any of the tabs?